Okay, let's solve a project management problem in here today. We have 7 activities given, and out of this, for these 7 activities, the immediate predecessors and 3 types of times are given here: optimistic, most probable, and pessimistic time. So the tasks are: we have to draw the project network, we have to calculate the expected variance, expected duration variance of each of the activities. Then you have to determine critical path. So actually, you have to make that. We have to draw the project network, and we have to calculate the duration and variance of critical path. So to do that one, the first task is project network. The project network actually depends on our number of tasks and immediate predecessor. So let's do it in here. So we will write first, we'll write start, and you see first 2 tasks. Let me make it, sorry. First 2 tasks, A and B, are not dependent on anything, so they can be started immediately. Task A or activity A and activity B. Activity C is dependent on A, activity C is dependent on A, and activity D is dependent on B. Activity D is dependent on B. Activity E is dependent on B and C. So activity E is dependent on, that was okay. Activity E is dependent on B and C. So activity E, we will write activity E in here, is dependent on B and C. Okay, and then activity F is dependent on D. F is dependent on D, and activity G is dependent on E. Activity G is dependent on E. That's all. So we now, once we are done with activity F and G, our project is done. So we can write finish in here. This is our project network. So this is the answer for question A, which says what is a project network. So this is a project network. And then once we have project network, then we have to calculate the expected duration, because we have 3 times given. From these 3 times, you have to calculate expected duration or expected time. I did it before, and I actually brought it here as a table, but I will show you how did I calculate it for 1 or 2. So let's see how to calculate expected duration for, say, first one, say activity A. So activity A has 3 times: optimistic time, most probable time, and pessimistic time. We will term them as, okay, let me name them here. The formula is like that: optimistic time A, pessimistic time B, and most probable time M. So the formula is ET, or expected time, equals to A plus 4M plus B divided by 6. So if we calculate this one for our activity A, that would be 8 times, 8 plus 4, so open to me, 4 times 10 plus 15, which is divided by 6, which is 40, 55, 63. 63 divided by 6, which is 10.5. See here, I wrote it by hand. And then the variance would be B minus A divided by 6 whole square. So our B for activity A, our B is 15, and A is 8 divided by 6 whole square. 15 minus 8 is 7, 7 by 6 whole square. If you calculate, you will see it will come something like 1.3611. So this is how we calculate our expected time and variance for each of the activity. and I calculated in here, so I don't have to do it here again. So that's it. So our activity 2 or activity requirement B is done. Then we have to calculate critical path. So actually, to calculate critical path, we will draw the whole project network. Then we'll understand what will be our critical path. Let's do it. To do that one, I actually drawn the boxes in here first. You can see the boxes following actually this project network from A. So the project network, A to C, B to D, and BC to E is here, A to C, C to E. So actually I just followed that one. It's the same thing. I just added 3 layers in here. Three layers means 3 rows. First row is for the name and the expected time. You see that I wrote expected time on the right side of the first row. A 10.5, B8, you see A 10.5, B8, A 10.5, B8, C 6.5. All the expected times are given here. And second row before earliest start and earliest finish, and third row before latest start and latest finish. So let's do it. As you can see from the project network, the first task or first activity A does not depend on anything, so we can start it from 0. Let me make it a bit bigger, easier to write. So it would be 0 plus 10.5, which is 10.5, and then we have our task B, which is also not dependent on anything, so it starts from 0, and 0 plus 8 is 8. Now activity C depends on A, so that would start from 10.5, and 10.5 plus 6.5 is 17. That ends in 17. And so this is earliest finish, and earliest start for E should be the highest of C and B, because if both of them are not done, you cannot start E. So highest is 17, so it can be started on 17th. And earliest finish should be 17 plus 5 is 22. And for okay, we can go that way first. And for 22, and G is only coming from E, so we don't have to worry about anything. So earliest start is 22. 22 plus 7.5 is 29.5. That's it. Okay. Now this stream is B to D, which is 8 plus 3, 11. Earliest start for F is 11. 11 plus 7 is 18. So the highest one between these two last activity is our project expected time, which is 29.5. Now we'll go backward to see our earliest finish and earliest start time. So earliest finish will be for G is 29.5, and 29.5 minus 7.5 is 22. And for F, same, we can do 29.5. 29.5 minus 7 is 22.5. And if G to E is 22, minus 5 is 17. And for F to D is 22.5 minus 3 is 19.5. Okay. Now from E to C, we don't have to worry, just C is going from just one of them. So 17 would be the latest finish, and latest start should be 17 minus 6.5, which is 10.5. But for B, it's going from E and D, so we will consider the highest one, because the lowest one, because it has to start, the next task has to start, and that one, so next task E depends on B also, B and C. So if B is not done, E cannot be done. So, and B, between E and D, the latest start, we will look at the latest start time. We have to take the smallest latest start time. So smallest latest start time is 17 in here. So we'll take 17. 17 minus 8, which is 9. And for A, that would be latest finish time is 10.5 and latest start time should be 0. So now you see here some of the task has same earliest start and latest start time. That means it has no slack. The task, the activities that has no slacks are our critical activity. So this is a critical activity, this is a critical activity, this is a critical activity, and this is a critical activity. These ones are not, because it has these three activities have slacks. So our critical path is A, C, E, G. You see here. So A, C, E, G. Now, how do we calculate project variance? And definitely, you see here the expect time for critical path is 29.5. Now, variance. How do we calculate variance? Actually, variance of the project is same as variance for the critical path. So we will see the project. We will see the variance for ACEG. Variance for A is 1.36. 1.36. I will take one more digit plus. C is 0.6944. 0.694 plus. E is 1.777. 1.777, and G is 1.361 once again. 1.361. 1.361. So let's get the variance in here. That would be, let me calculate. (1.361) plus 0.694 plus 1.777 plus 1.361. The 5.193. 5.193. This is our project variance, and this is our project expected time. That's all.